11, day 3 notes. Today we're going to talk about area of regular polygons and circles. Again, a regular polygon is a shape where all sides and angles are congruent. So the formula for area is A times P divided by 2, where the little a stands for apothem and the capital P stands for perimeter. Notes to remember: the apothem and the side must be perpendicular. So as you can see in our little illustration, the apothem is that line right there, and it's perpendicular with the side of the figure. And there's not only one apothem, so this is just an illustration of what an apothem would look like. Also, what you need to remember is that the apothem will bisect the side that it is perpendicular to. So some things that might help us solve our problems in the near future. So for number 1, we have a regular, I believe it's a pentagon. There's 1, 2, 3, 4, 5. All right, exactly. Yes, it's a pentagon. And we need to find the area. The apothem on this pentagon is 7. To find the perimeter, since it's a pentagon, it has 5 sides, and each side is 12 inches. So we just need to multiply 5 by 12 and we get 60. Or you can do 12 plus 12 plus 12 5 times. Either one, whichever works for you. To find the area, again, it's A times perimeter divided by 2. So that means 7 times 60 divided by 2. Now, anytime you have an even number in your numerator, you can kind of eliminate some work and calculator button pushing by reducing whatever that number is by half. So for example, half of 60 is 30. And half of 2 is 1. So now all I have to calculate is 7 times 30, which is a lot less work to do than calculating 7 times 60 then divided by 2. And 7 times 30 is going to give you 210. Our units is inches. And since I found area, I have to square them. So 210 inches squared. You can complete number 2 on your own. I'm going to jump to number 3 because I'm sure you're going to need my help. On number 3, we have an 1, 2, 3, 4, 5, 6, 7, 8. We have an octagon. And we need to find the apothem by using Pythagorean theorem. That's your hint. See, since this side is that 10, that is slanted, and it's not perpendicular with the side, so that's not your apothem. So again, the apothem has to be perpendicular. The right angle should be beside the line. In other words, it should not be some other line. So that's our clue to tell us that we don't have the apothem yet. But other things to remember is that the apothem also splits the side in half. So if each side of my octagon is 12, that means on each side of the apothem, we're going to have 6. So this part is 6 and this part is 6 because my apothem is right here. So my right triangle, I have one side is 6 and the hypotenuse is 10. My apothem is going to be this other side right here. So the shortcut for my apothem is that A is going to equal 10 squared minus 6 squared. Again, if I move too fast for you, ask questions later. But this is a shortcut. And when you calculate it out, you should get 8. So my apothem is 8. Now for my perimeter, since it's an octagon, it has 8 sides. And each side is 12. So 8 times 12 is 96. And now again, my area is my apothem times my perimeter over 2. So 8 times 96 over 2. Again, 8 is an even number, so I can go ahead and divide that by 2 to cut some work off. So this is 4. Again, this is 1. So now I just need to multiply 4 with 96. 384 units squared. Since I don't have units for this problem. 384 units squared. Final answer. Number 4 says the area of a regular hexagon is 200 feet squared. One other clue without actually having the word area in this problem is the fact that my units are squared. So another good reason why I'm going to hassle you to make sure you put the units beside each number and correctly labeled. It also mentions that the length of one side is 12. What is the length of the apothem? So again, the formula for area of a regular polygon, is apothem times perimeter over 2. Now, it gives us the area, it's 200, and it gives us the length of one side. So let's find the perimeter then. If it's a hexagon, it has 6 sides. And it says each side is 12. So that means my perimeter is 6 times 12, which is 72. And now, let's plug in everything where it belongs. So the area I will replace with 200 and the perimeter with 72. But the apothem and the 2 will stay in place. So, always, what you can do, turn this into a fraction and cross multiply. So 72 times my apothem is equal to 2 times 200, which is 400. And now I need to divide both sides by 72 to get my apothem by itself. So 400 divided by 72 is about 5.56. So my apothem is about 5.56 feet. Now here are some special cases. when you have an equilateral triangle or a regular hexagon, and you need to find the area. Things to remember about an equilateral triangle is that each angle is 60 degrees. And on an equilateral triangle, the apothem is essentially the height of the triangle. And again, it still does the same thing. Split it into two. So if the whole side is supposed to be 18, each side of the apothem is 9. So I took this equilateral triangle and I have now split it into two right triangles. And it also splits the angle. So this angle at the top, the 60, becomes 30 and 30 on each side. So it's a special right triangle, which we talked about a few weeks back. It's a 30, 60, 90 right triangle. On the 30, 60, 90, the pattern was across from 30 is x, across from 60 is x root 3, and across from 90 is 2x. On our right triangle, across from 30 is showing as 9. As you can see, here's 30, across from it is 9. Across from the 90-degree angle is 18, which makes sense because it's supposed to be 2 times whatever is across from 30. 2 times 9 is 18. So if this pattern is still true, then across from 60 is the height, which means it should be 9 square root of 3. Because if 9 is x, x is across from 30, and then for across from 60, so to take across from 30 and slap a root 3 on it. Now I can find the area of my triangle. We talked about this in the previous lesson. That's the area for a triangle is base times height over 2. The base of this triangle is 18. The height is what we just found. It was across from the 60-degree angle. So it's 9 square root 3. And then it's over 2. Again, the same rule can apply. Anytime you have an even number up top, go ahead and cut some of your work off. Divide 18 by 2, you get 9. And 2 by itself is 1. So you would eventually have 9 times 9, leaving the root alone. So it would be 81 root 3 feet squared would be the area of that triangle. Now try the other one on your own. Should be very similar, just some different numbers. Now for my hexagon, it's some of the same information. On a regular hexagon, I don't know if you recall, but each interior angle can be found by taking the sum of a hexagon, which is 720, divided by 6, and you get 120, right? So each one of these angles is 120. Now, my apothem comes from a center point on your hexagon. So let's say this is the center, and it's a line that leaves the center and hits the side. Like so. Again, it's going to be perpendicular with that side. So I'm going to have a right angle, and it's going to split the side into two equal parts. So if the entire side is 10, each part is, of course, 5. Now you could create another line like so to form a right triangle. What that line does is it splits that 120 degrees into two 60-degree angles. So again, I have now formed a 30, 60, 90 right triangle. So to find my apothem, it's across from the 60-degree angle. Across from the 30-degree angle is 5. So again, it's 30, 60, 90, x root 3, 2x. Across from 30 is 5, so across from 60 should be 5 root 3. So 5 root 3 is the apothem. Now to find the area, area is equal to apothem times perimeter divided by 2. We already know what the apothem is. The perimeter, let's pull that up to the side. Since it's a hexagon, it's 6-sided, and each side is 10. So that means the perimeter is 60. So my apothem again was 5 root 3. And I'm multiplying it with my perimeter, 60. And I'm dividing it by 2. Since 60 is even, I can cancel divide it by 2 right away and get 30. So now I just need to multiply 30 with 5, again leaving the root alone. So you would get 150 root 3 inches squared as the area of that regular hexagon. So please practice the other one on your own and ask questions to see if you get it right. I'll be happy to help. So that was it on regular polygons. We're now going to discuss area of circles, which you should be familiar with from middle school. Circumference is nothing but the perimeter of the circle, and we talked about this on a previous test. The circumference formula is 2 times pi times radius. However, the area formula is pi times radius squared. You could also find the circumference using diameter times pi, because if you take your 2 times your radius, you will have your diameter. So that's just an alternative formula to use. Alrighty. I will do the left side of these sample problems, leaving you to complete the right side on your own. So number 5 says, if D is equal to 13 feet, then C is equal to what? So C stands for circumference, and circumference is equal to diameter times pi. So that means my circumference will be equal to 13 pi, which is a great final answer. It's your exact answer. But if you want to grab a calculator to approximate, you're more than welcome to, but this 13 pi is perfectly fine on its own. So if the question says leave your answer in terms of pi, 13 pi is what type of answer they're looking for. But if they want you to approximate, that's when you go ahead and grab the calculator. And use the pi symbol. Don't use 3.14. So type 13 which is about 40.84. And it's feet. Circumference and perimeter, you don't do anything special to the units, just write them as is. For number 7, it says if C is equal to 7 pi inches, then the diameter is equal to what? So again, using the same formula, circumference is equal to diameter times pi. They are giving us the circumference in advance. It's 7 pi. So let's replace C with 7 pi, but bring down the right side of this equation, D times pi. So then if I want D to be left by itself, I would have to divide both sides by pi to cancel pi, which would tell me that 7 is equal to D. So D is 7 inches. Another good reason why it's best to leave your answer in its exact form. Number 9. If A is equal to 9 pi meters squared, then R is equal to what? A is for your area, and the area formula was pi times radius squared. So this is another instance where we would have to work backwards. They've already given us the area. I'm sorry, again, they've already given us the area. So we're going to replace A with 9 pi and bring the entire right side down. Again, to get the radius by itself, we'll first have to divide both sides by pi, which would leave us with 9 is equal to radius squared. But again, I want the radius. I don't want radius squared, so the next thing I would have to do is take the square root of both sides. So the radius is equal to 3. So 3 meters is your radius. So again, when you're writing your units, the only one that you square is area. All other units, write them as normal, please. And our last little tidbit on area is sector area, which we talked about prior to our last circle test. But just to remind you, sector area is nothing but a fraction of the area of the entire circle. So it's the area of a slice of a circle. So for example, I could find the area of the blue portion of the circle on this picture, or I could find the area of the white portion of the circle on this picture. But either way, the formula is measure of the arc divided by 360 times pi radius squared. So you remember this formula, right? Good, which you should. We talked about it previously. So now I need you to practice these two questions on, directly write them on page 96. I'm sorry. I believe it's 98 in your notebook. You probably want to draw the picture as well and write these two answers and its work for each problem on that one. And I will check it as well to see if you've done it right. This concludes your notes for today.